and thanks for joining me, Ms. Hallstrom, as we discuss the calculation for percent ionization of a molecular substance, in this case a base, when we are using osmotic pressure calculations. Okay, I've got the data on the next page, but we're going to make a little plan right here. The first step we're going to be using today is the osmotic pressure calculation, and oh my goodness, this value is the osmotic pressure. M stands for molarity. R is the ideal gas constant. And T, of course, is Kelvin temp. And we will be given this value, this value, this value, and we'll be solving for M. Okay, after we have M, after we've got molarity, we are going to use that molarity. That's going to be the molarity of particles. So I'm going to say the molarity of the dissociated particles is equal to the molarity of the solution plus some number. How much of the solution dissociated. For this one, this will be our calculated value. This will be this value right there. And we'll be given this value and we'll be solving for X. And once we have X, we will use our X to find our percent dissociated. Okay, now for some data. For the question that we're going to deal with as practice, we are given a base, HB, and I know that looks a lot like an acid, but that's what's given in the problem. And we are given an initial concentration of 0.100 molar aqueous solution. We are given an osmotic pressure of 2.83 atmospheres, a temperature of 25 degrees Celsius, which is 298 Kelvin, and R, we have to use the R that uses the atmospheres. So the ideal gas constant is 0.08205 L ATM over kmol. Okay, let's work. Let's do step one. And for step one, I'm just going to write little up here. Osmotic pressure equals M times R times T. So we're going to be solving for M equals osmotic pressure over RT. This is the equation we're using right here. So let's set this up. M equals 2.83 atmospheres divided by 0.08205 LATM over kmol. I get so tired of writing that unit out. And also divided by 298 Kelvin. Solving for molarity, our molarity is 0.1157 molar. And we'll worry about significant figures later. Okay, let's do the second step. For the second step, that one's pretty easy. We are going to use this value, which is our molarity of our dissociated particles and non-dissociated particles, equals, in fact, I should just write molarity total equals the molarity of our solution plus X, and that's our dissociated particles. So 0.1157 molar equals 0.100 molar plus X equals 0.0157 molar. Okay, and then last but not least, our last step, we're simply going to figure out what percent we have here, and to figure out our percent dissociation, we're going to take our dissociated molarity divided by our solution molarity, take that quantity times 100, and the answer is 15.7%. Not too tough of a calculation. It's not, I like to number my steps, keep track of things, make sure you list your givens, and identify what it is you're finding out. Thanks so much for joining me.